Hello, this is my recording for problem set 2, task 3. And I'm just going to, again, walk through the description of the problem set and explain what your task is in this video. I'm going to go ahead and reach over here. All right, so problem set 2, task 3 is diamonds. And this is really a task to help you get more practice with functions and abstraction. And modularity, how to define functions, how to use parameters to make functions more flexible, and it's a little bit of a puzzle. So the description is short, but it is a difficult problem to think through. So we have provided you with the file diamonds.py and you're supposed to define a 0-parameter function called diamond pattern. And your goal is to have that function produce the output, which is showing on my screen right now, which is shown on the web page for the problem set. I can't really describe it that easily in audio, but it is a series of diamonds in printed output. The diamonds are composed of one copy of the number 1, and then there's 2 copies of the number 2 below that, and then 3 copies of the number 3. And then we go back to 2 copies of the number 2 and 1 copy of the number 1. So it sort of gets wider and then narrower. And those numbers have spaces between them when there's multiple copies. That's one diamond. The whole diamond pattern has 4 diamonds with entire diamond width between them. Then it has 4 more diamonds on another row down where they're like offset by 1 space. So they fall in between the diamonds in the row above them, and then the last one is like afterwards. And so there's like these 2 rows of diamonds that are offset from another. That is a smaller part of the whole pattern, which involves 4 copies of that 2 diamond rows. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8 rows of diamonds, and each row of diamonds is a total of 5 lines tall. So that's a total of 40 printed lines of output. So your goal is to construct that pattern, and there's a few requirements that we have to make this problem more interesting. You could obviously just write 40 print statements, and you could write out, this is what shall be printed, right? But one of our requirements is, in the file, we have defined several strings for you. They are called 0, 1, 2, 3, and empty. 0 is a string that has 5 spaces in it. 1 is a string with 5 spaces, except the middle of those spaces, instead of being a space, is the number 1. So it's the top of the diamond pattern, and also the bottom. 2 is the second and fourth rows of the diamond pattern, so it is space, 2, space, 2, space. Again, 5 characters wide with those 2 2's in it. And then the variable 3 holds a string which is 3 space 3 space 3. So again, 5 characters, this time with 3 3's and 2 spaces. And so you can use these strings to construct the individual diamonds and the whole diamond pattern eventually. And the requirement is that you may only use these strings. You may not construct any new strings using single or double or triple quotes. You're allowed to have doc strings for your functions, that's the one exception, but you're not allowed to have any other strings that you use to print the output. You must use only those strings that are stored in those variables. There's one last variable I didn't mention, which is called empty. And empty is simply a pair of quotes next to each other. It is an empty string. It is a string with 0 content. And you might wonder why that is useful. And I'll just give you a hint that empty is the key to really reducing the number of print function calls that you use, which I'll talk about in a second. So, restriction number 2. Restriction number 1 being you can only use those strings. Restriction number 2 is you're only allowed to have 10 places in your program where the print function is called. Now, there are going to be 40 calls to the print function when your program is run. So this is not a restriction on how many times print gets called during the running of the program. This is a restriction on how many lines of code may have that function print written on them, right? And, you know, I could make a function that says print, print, print 3 times. I could call that function in another place 3 more times, and that would be a total of 9 prints, right? Each function call produces 3. So I can sort of increase the number of printed lines above the number of print function calls by repeatedly calling a function that has a print in it. And that's what you're going to have to do to get 40 lines of output after 10 print function calls. So those are our two main restrictions. You can only use those predefined strings, and you can have no more than 10 print places in your function where print is called. Okay, the other thing that is a restriction here is don't just define diamond pattern. You're required to define your own helper functions. It is up to you to decide what these functions should be called, what they should do, how they should come together to produce this pattern in the end, right? But it is your job to build those functions, and one of the restrictions that we have in place to enforce that is that, so several restrictions. One, the diamond pattern function must contain at least 2 function calls to other custom functions you've defined. It could be 2 calls to one other function, it could be 2 calls to 2 different functions, whatever, as long as they're 2 calls to other custom functions you're defining, not built-in functions, not functions we've provided you with. Additionally, your diamond pattern function may not call print directly. So of those 10 print calls, none of them are allowed to appear inside of diamond pattern itself. They all have to appear in other functions that are eventually called from diamond pattern indirectly. Okay, that's basically it for the major restrictions of the problem set. There's a bunch more details, and I'm going to go over the notes in the rubric, but the idea is use those strings, use a limited number of print function calls, and ultimately produce this big pattern. So, notes. Number 1, remember that every function you write must have a documentation string that describes what it does. We recommend you write these before writing the code for the function. This is a pretty universal requirement in this class for all of the tasks on all of the problem sets. Note number 2, there are possible solutions where one of the provided strings may not be necessary. So you don't have to use all of them. You're going to have to use at least all but one, but you don't necessarily have to use all of them. All right, rule number 3, you may concatenate the provided strings using storing them in variables that are already in variables, right, and using different operators to combine them, but you are not allowed to create any new strings with quotation marks, as I already described, and you may not use the new line character, which of course you can't use anyway because you can't create a new string, but just an extra emphasis on that. You're not allowed to use that new line character. Okay, another note. And this is one that I already covered. You're only allowed to use print 10 times in this task. And if you really want the extra goals and you want full 100% credit, you're only allowed to use it 5 times. So that's an extra challenge for you. This is possible if you define helper functions to abstract over common patterns. So try to make your program as simple and elegant as possible. Right. Another rule, you are not allowed to use features of Python we have not studied yet, even if you know them. No if statements, no loops, especially for loops and while loops, right? These are things that could also make this problem really trivial, but you're not allowed to use them. We want you to focus on how to use functions to achieve this goal, to really deepen your understanding of how to use functions efficiently. Okay, another note here, which is not a restriction anymore. It says the goal of this problem is twofold: to recognize patterns and to write functions that can generate these patterns and combine them together to produce the complete pattern. We strongly recommend that you spend some time thinking about how to break the drawing of the output into different patterns that can be captured by simple functions. If you're having difficulty recognizing these patterns, we have a diagram to help you with the process. Access the diagram only after pondering the pattern on your own. And there's a click thing, expand thing here you can use to show the diagram. I'm going to show it briefly, although again I recommend you ponder on your own. It's sort of showing how the overall output can be divided into smaller groupings, kind of like I explained at the beginning, where there's like a row of diamonds and then a shifted row. And those two things together make this row shifted row pair. And then if you took that pair and repeated it several times, you would get the entire pattern. So the row shifted row, those are like slightly different things, but they're similar things. How can we capture that similarity through abstraction? Right, a few more notes. This problem has many solutions. There's even a particularly elegant solution that only has one call to the print function. Not 5, not 10, but just one. We don't require that you do that, but if you want an extra challenge, go for it. There's another requirement here. For a perfect score, you must also make no more than 8 function calls of any kind within the diamond pattern function itself. So diamond pattern shouldn't have 40 calls to some other function that calls print or something like that. Like, it should have no more than 8 function calls. So again, think about simplicity, elegance, being efficient. And then final note, in the description so far, we've been referring to the function just by its name. When you invoke it in the console, you'll need to actually include the parentheses to call it. All right, so that is the description of task 3. I'm going to go over the rubric again for those detailed guidelines on how you will be graded. But it's pretty much the same things I've already said. So what are the core goals for this function? Goal 1 is kind of a freebie. No errors loading your code, right? No syntax errors, no whatever, like no errors. Get that goal for pretty much free. Core goal number 2, the output of diamond pattern should be correct, right? So this is the big one, and there's an example of what that output should look like here as well. But that is the exact pattern that you must match for your output to be correct. Core goal number 3, all your functions must be documented. This is a common goal in a lot of these problem set tasks. Core goal number 4, you must call print in at most 10 places. And this is throughout the entire file. This is excluding any testing code that we've provided, but don't add any prints for your own testing code, or if you do, please delete them. It's in the entire file, call print in at most 10 places. Core goal number 5, define the diamond pattern function, right? So how are we going to define this? What are the restrictions? Well, there's 2 restrictions. Number 1, do not call print. So do not call print directly inside of diamond pattern. You have to call it indirectly. Rule number 2, there have to be at least 2 calls to locally defined functions. At least 1 custom function defined or called twice, or 2 different functions called once each. You're welcome to call more than twice. You can go above 2. There have to be at least 2. All right, next core goal is don't use if statements. Kind of a freebie, right? And next one is don't use for loops. Also kind of a freebie. We haven't even talked about what these things are yet. But if you happen to know what they are, don't use them or you will fail these goals. All right, so how about extra goals for this task? Number 1 is call print in at most 5 places. So it's a narrowing of that restriction. Number 2 is in your definition of diamond pattern, don't make too many direct function calls. So don't make more than 8 function calls. That's an extra goal, not a core goal. And finally, do not create any strings other than those provided. So you could violate that if you want to just go for the core goals and forget about the extra goals, but we suggest that you don't. So those are the goals in the rubric for problem set 2 task 3. Fairly simple compared to some of our other tasks in terms of the specific goals required. Still a complex problem to solve. This is the end of my recording for this problem set, and I will try to make these recordings for other problem sets as we go forward.